Thank you. Okay, you're all set.
Okay, perfect. Well, thank you, Mark. Thank you, Troy, and thank you, Nkosi, for the opportunity here to speak at the Model-Based Systems Engineering Lightning Round. It's always been one of my favorite events, so it's a great honor for me to be able to be involved. Now I realize I'm a fairly new face for many of you, and I want to take a moment to introduce myself. I'm Devon Clark. I've been working for about 20 years in some form of system engineering, integration, and test. I spent the first 18 years working for the Navy in Naval Sea Systems Command, doing combat systems, command and control systems for surface platforms. And I've spent the last 2 years working with Deloitte. And yes, that Deloitte. Big Four accounting firm Deloitte, multinational Deloitte in over 150 countries with over 300,000 employees, doing consulting, advisory, tax, and audit. And with all of that broad perspective, working with so many government agencies and working with so many industry partners, there's really one question that I get asked all the time that I think is so critical. It might be the most important question that any of us face this week, and it's quite simple. It's just this: what is a tax firm doing here and talking about model-based systems engineering? Let that pause and sink in for a moment. Now, it's a fair question. That's one I get a lot, but we actually do have a really kind of important answer here, right? Which is that long before we started talking about model-based system engineering and digital engineering, long before that, Deloitte, our reputation has been around technical innovation. So Deloitte does digital, and Deloitte does transformation. And so with the focus now on Industry 4.0 and moving to more connected and interconnected and complex systems, the focus on model-based system engineering, model-based engineering, digital thread, digital engineering, digital transformation, I'm here to tell you that Deloitte does digital transformation. Now, there are lots of firms out there that claim that. There are and what makes us different, I would assert to you, is that a lot of those companies, they say that, and they're doing very important work, but I would say that they're only doing digital. What's different is kind of what we want to talk about. So let me take a moment to really define those terms. So these definitions are coming from the Oxford Dictionary, and digital, pertaining to and being around computer-based technology. Transformation, a change in form or structure where the end is significantly different than the initial state. So is it a digital transformation? And you can all nod knowingly and have a knowing grin if this sounds familiar. Is it a digital transformation to take your DODAF views and then move them from Visio into SysML, but not to change your processes, not to change what you do with that information? Is that a digital transformation? It's an important step, but it's not a digital transformation in and of itself. So what we're here today to do is really to try to deliver a different idea about what it means to be digital and how to actuate that in itself. And I think that idea is going to resonate. It's very simple. It's very elegant. All we have to do is turn to Einstein's relativity. Now, when Einstein was thinking about Maxwell electrodynamics, no? Okay, all right. So let me try to reduce it even a little further. So what did Einstein really do? And what did relativity do? It connected mass and energy and how things move through space and time. So if we think about that for a second, there are really kind of three core principles that we can take away. First is that things that have a lot of mass take a lot of energy to move at great speeds. If you have no mass, then you can move at the speed of light, things like light and information and electricity. So I'm going to make a substitution here. I'm just going to say that things that have no mass can move at the speed of information. So if you want your thing, your business, your organization, to move at great speeds, at greater speeds, the most important, you have one single imperative, which is get the mass out. You want to get the mass out to move at the speed of information. Now, you might be asking me, maybe you're not, but go with me because this is part of the narrative flow. You might be asking me, Devon, how can a business have mass? Well, there's a few examples. We'll just focus on three. We are all engineers. We author and develop, design and generate artifacts. Those artifacts exist in paper if we've moved on into now actually having electronic copies, but those electronic copies, I know for myself, exist on my laptop, not on the cloud, right? And so those computers and the network architecture and all of those, and maybe the cabinets where the physical copies of those reports exist, all of that has mass. We can talk about reviews. Now, I mean, you're all here today. We're reviewing some of the work that the working groups have done over the past year. I don't know about you, but I came in from DC, and so all of us as people, we have mass. This facility has mass. The airplane that I took to get here and the fuel has mass. The maintenance systems that were working on the other plane that kept me on the tarmac for an hour before I could actually get off the airplane, those all have mass. All of those things have mass. We can also talk about production, right? The materials, the facilities, also the fleets of vehicles that have to move parts around and end items once they've been produced. All of those things have mass as well. So a question that I have for you is imagine for yourself, imagine in your day-to-day, in your job, there's probably something that involves a lot of things in the real world that have to interact. What if you could take that and replace it with just the information that describes it, and you could connect it to other information about other processes and other things you have to interact with in the world? Would that accelerate your ability to do work? Would that actually change the things that you could do? Would that transform your organization? I believe the answer is yes, and that's partially what we want to talk about. So how can we get the mass out? Well, we have, our vision of this is what we like to refer to as the PD-DP loop. You'll notice we have an outer loop which goes from physical to digital, and we also go from digital to physical. So the idea being, we want to take things that exist in the real world, we want to replace them with information. And once we have that information, we want to use it to create movement in the real world. But there's the most important component here is that inner loop, that digital loop. That's where model-based system engineering resides. You know, I work with a lot of our staff at Deloitte, and one of the things I like to tell people, just not around engineering, just in general, is that ideas inform decisions, and decisions inform actions. So if we apply that same question that I asked before, what would that look like if that was entirely digital? Well, actions, that's around automation and robotics. Decisions are around artificial intelligence. Ideas, those are the things that we know and assume. Those are being represented by models. So model-based system engineering, SysML, all the things that we are so passionate about are such a critical enabler to this entire transformation. So let's go ahead and take a moment to look through each phase of this. First, we want to take the things in the real world and we want to establish a digital record. We want to ingest the real world into the digital space. Next, we want to connect that information. We want to create means of visualizing and analyzing that data, which and this is probably the most critical part, which will allow us to translate between contexts. Once we can do that, then we can actually generate movement in the real world, and then we will have an engine for change. So going back to those examples I went through in just a second ago, let's return and let's talk about authorship and about the development of artifacts. So over there on the right, we see that there's a stack of papers right there next to a computer. Now, how are we going to get all the information in those papers into that computer? Well, we could apply natural language processing and artificial intelligence. Requirements have a fairly deep structure to them. Like we have certain conditions which might reflect a state machine. We have an actor, the system shall. That system is representative of a block. It shall do something. Do something is a behavior, right? And it shall do something to a certain level of performance. Well, the level of performance is constraints. So what if we were to take all of that information, just the text in those documents, those papers, and we were able to run them through a natural language processor which could generate a 25 or 30% SysML model just based on what's in that paper already. So that's one example. I took a little more time with that one, but that's an example of kind of how we're thinking about this, how to take the real world, the physical, and ingest it into the digital. Once it's there, and we have these SysML models to work with, we can start operating on them and working on them and in digital space. And then, and this was brought up earlier, we can also then connect those models, maybe through the Internet of Things, and through digital twins to be able to have our system start self-monitoring and actually start to adjust and revise those models and keep that loop going. If we look at reviews, well, we just talked about digital twin. We can take a digital twin and move it into virtual space and actually explore that in virtual reality to be able to see, but long before we ever produce a prototype part, whether or not that form factor is going to actually work with the human-centered design and human factors, or whether it's going to be maintainable, or how training is going to have to be adjusted. And then, of course, when we do want to walk through the details of that with all of the stakeholders, we can work through virtual campuses and virtual meetings and in collaborative environments and integrated system engineering environments to do those reviews. If I think through how we do production, we can actually use intelligent sensors like drones to go out and do a 3D survey of a system. Maybe that system has had some kind of casualty or failure, and it's able to bring that back into a finite element analysis or a CAD model, which we can then use to generate a custom part using 3D printing or additive manufacturing that exists on site rather than having to go through the logistics and supply chains. So these are all just examples of, just a few examples of how we might think about digital transformation in the future. There are more. I haven't taken the time to count all these dots here. Let me see. Yep, there's more than one. So I know that in this, we like to focus a lot on model-based system engineering. And I don't believe it's called out specifically on here, but it is up there. Right? Now, the point is, and this is perhaps the big takeaway I wanted to bring up here today, is that digital transformation absolutely must include more than simply model-based system engineering. We have to look beyond. I haven't even brought up blockchain or quantum computing or cloud and DevOps. I haven't brought up any of those, and. There's many more and that we have to be thinking about. Now, this is still all technology. One of the core things, and perhaps the biggest thing that we have to change in order to be able to transform our organizations is the organization itself, our people. So are we ready? Is your organization ready? Now, earlier on in this discussion, I mentioned that most organizations simply are doing digital. Now, some of us perhaps maybe we're exploring. We're looking at some technologies that might be able to help us with our processes. Some of us have actually taken those DODAF views and put them into SysML, and we're done, right? Now, a lot of organizations stop there, but we shouldn't. We should move beyond. We should start to look at, once we have that information digitized and connected, what can we do with it? How can we advance our business by learning how to use that information? And ultimately to the point where the data that we have that exists in this digital space is changing our operating model on a day-to-day basis. We're very fluid and dynamic. And perhaps the core takeaway from this view right here is that it is not technology that is going to move us up that curve. It is how we think and how we operate. We have to change that model in order to be able to get there. Now, that's a fairly tall order. So how do we do that? Well, we can help there too. So if this organization is who we are as a business, then we have to look at our DNA. And is digital in our DNA? Now, we've done some research that has identified 23 traits of organizations that operate very digitally. Now, there are other organizations who have done very similar research, but this is ours. And the core points I want to focus on here are the assess, enable, and then transform. Right, so you've heard some talking about like finding the small things that can make a difference. That's what we're talking about with assess. Once we have identified that champion, let's work with the champion and those leaders to see how do we rate ourselves on each of these 23 different topics. And where there is the opportunity for change, let's start identifying the smallest the smallest changes that we can implement that are going to make a difference. That's how we will start to enable transformation in the long run. Once we have that list of changes, of those minimally viable changes, now we work with leadership to start organizing them into plans, because once one small change that has a massive impact takes hold, it will accelerate and build momentum towards all the rest. So this is how we're able to transform ourselves and be able to look at that organization and how we can get the mass out, which will focus us to the last thing, which is, hopefully I've been able to prove that if we can remove the mass from our organizations, it will take less energy to move at speed. So get the mass out to move at the speed of information. Thank you very much.